In the previous example of a 3D sketch, the geometry we created lined up with the standard coordinate system. That is, all lines were either in the X, Y, or Z directions of the reference triad shown on the lower left-hand corner of the graphics area. In this example, we want to take a look at how to create geometry that does not fit into the XYZ system. This is the geometry I want to create. You can see a portion of the sketch lies at an angle of 45 degrees in relation to the top plane. Before I begin the sketch, I'll create a plane to serve as a reference. By the way, it's not necessary that you create reference planes ahead of time like I'm doing here. This is simply one approach. In the next lesson, we'll take a look at using planes created on the fly. To create an angled plane here, I'll begin by putting a line on the top plane and use it to define an angled plane at 45 degrees. If your sketch will require several reference planes, it's a good idea to rename them so you can identify them easily as you sketch. Here I'll simply call this plane 45 degrees. Now I'll start a new 3D sketch and activate the line tool. As you saw earlier, the red arrows will appear indicating the orientation of the sketch. I want to create the angled portion, and I want to use the angled plane I just created to do so. Instead of just sketching a line, I'll turn off the line tool and pre-select the angled plane. I can do this from the Feature Manager tree or the graphics area. With the plane selected, I'll turn on the line tool, and notice the red arrows are different now. They line up in the same orientation as the angled plane, indicating that the coordinate system I'm using has changed. Instead of the front plane serving as the XY plane, now this angled plane is the XY plane. I'll begin with a line starting at the origin and going in the vertical relation. Remember, vertical is in reference to the angled plane. Next, I'll sketch a horizontal line and another vertical line. Notice I'm snapping to the yellow inference lines to automatically capture vertical and horizontal relations as I sketch. Of course, these can be added later, but this saves me a couple of steps. Now that I've created the lines that lie in the angled plane, I need to create a short line that is perpendicular to the angled plane. To access this direction, I'll use the Tab key to sketch a line along the Z direction. Next, I want to sketch in the same orientation as the top plane, so I want to stop using the angled plane as a reference, and to do this I simply turn off the line tool and turn it back on. The red arrows now line up with the reference triad once again. I'll continue with the geometry. And to complete the sketch, I'll click on the origin. Notice that although I was sketching in the orientation of the top plane, by clicking on the origin, the line will attach itself, even if the origin does not lie in the same plane. I didn't have to use the Tab key. I simply click on an existing point and the 3D sketch will connect to it. Now to define the sketch. The first thing is to align these 2 points using the along X relation, as well as these 2 points. Next, I want this small angled line to be perpendicular to the angled plane. This way, it will be parallel to the other short segment. To accomplish this, I'll select the angled plane and the line and select the perpendicular relation. When working with 3D sketches, it's common to use planes as references for geometric relations and for dimensions. For instance, the next thing I want to do is dimension this line from this point. However, if I select the point, I don't get the dimension to align the way I want. Instead, I get the shortest distance between the two. To get the alignment I want, I can select the front reference plane from the Feature Manager and dimension to the line. This gives me the alignment I was looking for. I'll finish up with a few more dimensions and some fillets. There you have an example of creating 3D sketch geometry on angled planes.